Have some questions you can omit on this. Oh, sorry. I'm just starting off right on the video. Hi, online people. Welcome to dual credit geology class. I'm going to introduce a lab today, and I just want to go over it real quickly so everybody kind of has an idea what to do. And I make a video about it. So if you forget by the time next week rolls around and you're doing the lab, you can come back in and check on the video or send me an email, and we'll get through it together. This is actually a really good lab. That was just for us here in class. So this is actually a really good lab. It's fully self-contained. If you read through everything, it should explain everything that you need to know, and should be able to answer all the questions. So if you ever get to a question and you're like, I don't know what this is asking for me, make sure you go back to the previous paragraph or section and read the actual reading involved in it. Because if you just go directly to the questions, it might get a little bit confusing. If you go start from the top and read all the way through it, it's not going to be too bad. It does look like a really long lab. And to be fair, it's probably a little bit longer than the ones that we've done before. And if y'all need more time on it, we can have more time than just next week. Just let me know. I'll look at how everybody's doing on it, and we can go through that. So you're pretty much going to do the lab on paper, and then I'm going to have, well, we'll see how this goes. No, with this one, I'm going to have a Canvas submission on Canvas, and I'm going to want you to at least just transfer your answers directly into Canvas. That will make grading a little bit easier because unlike the other one, which is more like word answers or drawing answers, this one's pretty analytical, and so you should be able to put the answers directly in there, and it'll grade it automatically, which will be better. So there are some things you will need to do physically on a piece of paper here. I guess technically you could do it on a computer screen, but it might get a little bit dicey. So that's why I printed this out for y'all. And we're going to go through some of the questions, how to do a little bit of it. And we'll start off very quickly with the questions you need to omit. So there's some that aren't necessarily super important. I'm trying to find a way where there's no glare here. Yeah, you can see them there. Nice. So number 1 through 3, you're not going to be able to answer. Some of these you can't answer because the figure that they refer to is not there or is not very legible after all the times that I've copied it over the years. I've actually been using this quite a long time. I know that I used it at Cedar Valley, and then I've been using it every year since I got here. So 1 through 3, don't worry about number 1 through 3. You can cross those out and omit those. Number 6, but not the entire number 6, just part C. So you still need to do 6A and 6B. Just don't worry about part C for number 6. You can cross out 11, 12, 13, and 14. 11, 12, 13, and 14, do not answer those. And at the very end of the lab, on the last page, there's a companion website section. Don't worry about that. I don't think that website even works anymore. And so just cross out the companion website section. That being said, the rest of the questions are up for grabs. For the most part, they're all going to kind of lead you down a path to understanding a little bit more about plate tectonics and how we study it, how we understand the plate movements, and how we get a little bit of math going on with it. So let's look at some of the questions and how we're going to be doing this. One thing I will point out, this is a kind of long lab. The figure they're referring to isn't always on the page that the questions are at. So you might have to do some flipping back and forth from one page to another. Like I think right here, we have figure 3, and then the question just below it references figure 4. And so you will have to go to the next page to see figure 4 and to answer those questions. So make sure you're looking at the correct figure, especially if you read a question and you're like, this doesn't make sense. Make sure you're looking at the right figure if there's a figure involved. But if the figure's not here in the lab, if it was on a different page, I should already have those omitted, so I think I've taken care of that. Basically, they're going to ask you some questions about plate tectonic stuff, like this one's going to be divergent, this one's going to be convergent, and that one's going to be transform. They're going to ask you about the different types of plate boundaries. So you have continental, oceanic, oceanic, and then continental, continental. So it's going to ask you those kind of things. The difficult parts will be that there's a little bit of math involved, and there's a little bit of measuring involved. So let me show you how to do the measuring, which is actually going to help out quite a bit. There's two ways to do this. You can do it with a ruler, which works just fine, but you can also do it with a piece of paper, which in my opinion works a little bit better. What they're going to ask you to do is make an on-paper measurement on your map or whatever figure they're talking about, because there's other figures you have to do this. Make an on-paper measurement and translate that into a real-life measurement. So like if I measure from New York here to the northwestern coast of Africa, how far is that distance there? So you're going to go in with your ruler, and obviously on your piece of paper it's going to be a little bit different, and you should be able to see the scale a little bit better. And you're actually going to measure this. This one is like not quite 4 3/4, and this is why I think the piece of paper works a little bit better, because you don't have to worry about the actual inch distance. You can just mark it on a piece of paper, and it makes it a little bit easier. So I'll show you that in a second. But I'm going to say this is like 4 5/8. That's right about what it looks like. 4 5/8. I'm going to take my ruler down here to the scale at the bottom. Note that this has two scales, miles and kilometers. They're more than likely going to always want you to work in kilometers. So make sure you're using the kilometer scale. I'm going to line my ruler up with a 0 and see where is 4 5/8. Where does that come out? It's hard to see on this one. This one looks like it's just shy of 7,000 kilometers. Be as accurate as you can. If you think it's 7,000 exactly, put 7,000. If you know it's a little bit less, put 6,800 or 6,700, whatever you think it is. But try to be as accurate as you can on these. Now, if you use a piece of paper, just be aware if you're making a lot of marks, which mark you have. Maybe make them a different color or longer, or draw like the question number next to it so you can kind of keep track of them. And maybe keep track of your pen. I use my pencil here. No, there it is. So I'm going to do the same thing. If I go from C to D, from the South American coast to the African coast here in the little inlet, I line up my paper with the point on C. I make a mark on D. And that's my distance. Now I don't have to worry about inches or like 5/8 or 3/16 or whatever it happens to be. I can just slide this down to the scale, line it up again, and obviously this will be a little bit easier on your actual piece of paper. And I can see that this is, in between, what is that? In between 4,000 and 6,000. So somewhere close to 5,000 kilometers there. And so that's how you're going to get your distance measurement. Then once you get that, because this is plate tectonics, they're going to want to turn this into a rate, a number of years or a number of centimeters per year. So actually the difficult math part is going to be converting from centimeters to, why do I always bring my markers way back over here? Converting from kilometers, which you just measured in on the map, very long distances across the entire ocean, to centimeters, little tiny centimeters that are on your ruler. It's not too hard, and this will actually be in the video. I bring the Chromebook over here. So you can look this up, and let's be honest, there's people at home and y'all have a lot of stuff to do. So if you wanna like Google this and just be like, how many centimeters are in this many kilometers, go for it. It's not going to hurt anybody. But if you want to do the math, a little bit extra math, it's not too bad. 100 centimeters equals 1 meter, and then I did that wrong. 1,000 meters is equal to 1 kilometer. So you want to go from kilometers to centimeters. You're going from a big unit to a small unit. So if my unit's getting smaller, my number should be getting bigger because I'm keeping the distance the same. I'm just changing my units. So if my unit gets smaller, my number should get bigger. So I'm going to multiply by both of these numbers. Or if you add them to, if you multiply them together and then multiply by that, you're going to multiply by 100,000. So if I have 5 kilometers, it would be 500,000 centimeters. Does that make sense? And so once you get that, let's just say we have 500,000 centimeters. And let's say it took our plate, I don't know what's a good thing. Let's just say 100 years to do that. 100 years. No, that's not right at all. This is going to be way too fast. Let's say it was 100,000 years. There we go. 100,000 years. Yeah, that's fair. This is going to get you your actual rate. And so you would divide this, 500,000 divided by 100,000 is going to get you 5 centimeters per year. And so that's a pretty good rate for plate tectonics. So one thing to point out, if you measure in kilometers or some other large unit, you need to convert to centimeters before you do this last little bit of math. And the second part is if they give you like 5 million years, you need to actually write out 5 million years and not just divide by 5. So if you divide by 5, it's going to be way too big of a number. If you divide by 5 million with all the zeros, that's going to get you your actual true answer. So if they give it to you in millions of years, convert it to regular years, not the millions part. So that's the kind of stuff you're going to do. The instructions are pretty good, like I said. You're going to have a couple instances where you do that. Here's the magnetic pole flipping. So we saw an image like this in the PowerPoint. So if you want to go back and reference the PowerPoint, you can. But you have, this one's actually opposite of the PowerPoint. In the PowerPoint, the white intervals were the normal polarity and the dark intervals were the reverse polarity. And this one, it's opposite. The dark intervals are normal because we are in a normal polarity interval right now. And then the light ones are your reverse ones. So it just gets flipped. Down here, they actually do a spreading center kind of exercise. So they're going to ask you, first off, to label all of these intervals on the other ones. So you can see that this dark one right here is E. You have E up here. It's going to be the same E. And if you look, you're going to have the same kind of sequence. Dark, a little light one, a little dark one, like medium-sized light one, a dark one, another light one, a dark one with a little light in between, and then the really black one. And so all of these should match up. Now, this one has the same stuff. It just doesn't show all the way out to E. And so as you're labeling things, you have A, you have your little light gap in between it, and then you get to B. You have your other little light gap, and then you get to C. So make sure that you're seeing the pattern here on each of these sides. And then they're going to ask you to do the distances just like you did before. You're going to come in here and say, how far away is A and C? You make a mark on your paper or on your ruler. You drag this down to the scale, and you figure out how many kilometers that the spreading center is opened up, and they'll give you a time frame, and you can figure out how fast each of these are kind of moving. And know that it doesn't matter where you're at. So these are 3 different areas. You have the North Atlantic Ocean, the South Atlantic Ocean, and then the Pacific Ocean. If this is C and that is C up here, wherever C would be, that would be C. If from current time to C is 2 million years here, it's also going to be 2 million years here and 2 million years here. The time frame should stay the same because you're talking about a global magnetic flip. That magnetic flip isn't going to happen at different times for different parts of the world. It happens for the whole globe at the same time. This is where they get into some math stuff, but once you start to do the math, it's not too bad. You convert it from kilometers to centimeters, you divide by the number of years, and they will kind of lead you each step of the way. And so some of the questions, you don't even have to do it all at once. Like here, what are the kilometers? What are the centimeters? And they actually tell you what math to do to get to centimeters. And then divide by the years, and they have a different answer for that. So it kind of leads you through that process, which isn't too bad. Here on Hawaii, if this image is too bad for you to see, let me know, because I will get you a better image here. But essentially, you're going to do this same thing. You're going to measure from the hot spot right here, which is the current place that your hot spot is, all the way to the far island of Kauai. My paper's not quite long enough here. I don't think my ruler's going to be long enough either. But you measure all the way to Kauai from your hot spot. Yours will be smaller, so you should be able to do it with a ruler or a piece of paper. And then you're going to have to come in here and get your distance. Notice your scale bar is actually smaller than the distance you need to measure. So, for example, I'm going to make this a little bit shorter. It's not accurate. But let's say I measure my hot spot, and I come all the way out here to the end of my piece of paper. I just need to do several measurements to get my overall total distance. So I'm going to line this up with my mark, and I'm going to say, okay, this is 200 kilometers. And then I'm going to move this over to the end and get the last little bit. So I would have 100 here and close to 125. I'm just estimating, but I would need to add those two because I kind of do two different segments. So it would be like 325, which isn't what this one is. You'll have to actually measure it because my piece of paper doesn't go that far. But that's what you need to do. If your measurement is longer than your scale bar, just kind of chop it up into segments to see how far it is. And then that's it. It seems like a lot, and I know it'll be a lot. If you have questions, let me know. If you need extra time, let me know. Anybody can have extra time on this one. I will just push the date back in the Canvas submission thing, but I will get that up. Work on make sure you get your homework done. If you need more time over the weekend for the homework, that's fine, but know that we are taking the test tomorrow. So if you get the homework done, you should do a lot better on the test. And if you have any questions, please let me know. I will email the omitted questions to y'all online, although it is here on the video. So make sure you come back and watch the videos. So y'all have a nice day, and I will see you for the test tomorrow.